All right, well, welcome, ladies and gents, and our final problem. All right, see if we can put all this together, make it a little bit easier for us. We have a restricted domain in this problem of 0 to 2 pi. We're going to find all the solutions of the equation in the interval. So what does solution mean? It basically means solve for x. Solve for x. Find all the solutions. So that means all the possible solutions on an interval from 0 to 2 pi. All right. So that means we don't need any coterminal. So no coterminal, no coterminal. All right, because we're only looking for values between 0 and 2 pi, and that's all we really need right now. All right, so without further ado, all right, let's see how we do this. Now, this one looks really complicated. I know to most trig students, you're going to try it out and try it yourself and then see the solutions at the end. Go right ahead. You can pause it now. All right, time's up. So I'm going to go now and talk you through this one. So whenever you have this, just do algebra. It's algebra, okay? If you have this problem, one of the key things in algebra is you always want to make something equal to 0, okay, and factor if possible, okay? So right here, what we're going to do is I'm going to take this, I'm going to subtract that to the other side. So I want to make this equation equal to 0. That's one of the main things in algebra that you want to do. Now, some students say, well, couldn't you divide by cosecant of x right away? You could, but what we call is that you sometimes lose a root. All right, now this or solution, a root or a solution when you divide those out. Now in this case you won't, and I'll show you in just a little bit, but just be careful, don't do that. I just subtract the other side. Now from here, I sing a little song to myself. One of these things is just like the other. What can we factor out? Now, if you're not catching that, this same thing would be like, for example, if I had z times y minus 2y equals 0. All right, here's a y. All right, what can I do? Well, one of these things, just like that, what can I figure out? Well, I can figure out y. I'll figure out y, I'll have z minus 2, all right, equals 0, and I would solve. All right, y could equal 0, and then z could equal 2, and those would be my two solutions for y and z, because whenever you have factors equaling to 0, that's why we do it, because it's really easy to figure out what zeros are when there's multiplication involved. That's why you have it. Okay, so whenever you can possibly factor, you do it. So in this case, we're going to do it. I'm going to factor out, in this case, cosecant x, because that's what's common between both of these. And so when we factor out the cosecant, what do we have left over is secant of x, which is just like our z, all right, minus our 2. And that's going to set equal to 0. Now, next thing is, what makes cosecant 0? Well, cosecant, all right, will be, I don't know, what will make it 0, but I know what this will be 0 when cosecant equals 0. We know over here, this will be 0 when secant of x equals 2, right? When secant of x equals 2, because this needs to be 2, all right, in order to make it 0, so we can get 0 times cosecant. So these are our two solutions. Now, how do you solve these? Well, you can't just solve this and this verbatim, so we actually need to change this to sine and cosine. So change to sine and cosine. We're going to make this end 1 over sine of x equal to 0. This one will be 1 over cosine of x, and that's going to equal 2. Now we're going to solve this. Now, once again, this is like our previous problem. If you looked at my problem number 5, is that we have a rational function equals 0. It's only when the numerator equals 0, and therefore, guess what? This will never equal 0. There is no solution to this particular problem. And that's why I said previous, if you happen to divide by cosecant here in the beginning, get rid of it. You want the loss of solution because there was no solution to be lost in this case. But don't do that every other time because you just may end up losing a solution. Bad. So this one just kind of confirms that there wasn't one. All right, now here, we're going to multiply both sides by cosine, divide by 2, and I'm going to write all that out. So we're going to have 1/2 equals cosine of x. I'm just doing means and extremes, a little bit of algebra and proportions and whatnot. So we have 1/2 equals cosine of x. Hey, we've done something like this before. In order to solve this, we're going to take our cosine of 1/2, and that's going to be x, right? We take our cosine both sides. And now let's solve this. Well, cosine, we are looking for all the solutions from, what does it say? 0 to 2 pi, 0 to 2 pi. All right, 0 to, now, our cosine. All right, so what angles give us cosine? Where is cosine going to be positive? Cosine is positive in the first quadrant and also in the fourth quadrant, because that's when x is positive. All right, and the cosine is x. Cosine x, y, sine y. You think I'm weird? Yeah, I am. All right, so in any case, we got that right there. We have 1 and 2. What am I doing? That's a 1, that's a sign. All right, we got a 1 down here and a 2. All right, and we're looking for this angle, and we're looking for that angle right there. And so, from here, what is that going to be? Well, we have a 1 here. That means this is going to be radical 3. This is going to be negative radical 3. All right, what has radical 3 opposite of it? Well, we know that's going to be pi over 3, which is 60 degrees. Do we need to add our coterminal? No, we do not need to add the coterminal because we're only looking for a solution between 0 and 2 pi. 0 and 2 pi. Right here, our other solution would have to be, well, what's in the fourth quadrant? Well, that would have to be 5 pi over 3. 5 pi over 3. And that would be our other one because that would be going right there. Do we have to add our coterminal? We do not have to add our coterminal, once again, because we are only going from 0 to 2 pi. So no coterminal in either one of those cases. And guess what? That is just our answer. It was just that easy. Yeah, it was not too hard. All right, so we did it. We used factoring again. We used some algebra. Factor it out. All right, figure out when this equals 0 and when this equals 0. Set it up. Solve it. Make sure you put in sine and cosine when you have secant, or cosecant and cotangent, or put in terms of tangent as well. All right, solve it. These happen to be very easy ones, which you should know your circle chart. You should know those values. If you don't, you got to say those. Those are important. All right, and that's how we find our values. Well, I hope this helps you out. This is the last, well, maybe the last one. At least I got 6 problems out there for those that may be struggling with trig on how to solve trigonometric equations. All right, it's all algebra, my friends, but make sure, key things, use your inverse properties. All right, understand when you need coterminal and non-coterminal angles. And those are basically the basics of how to solve, all right, trigonometric equations. All right, well, good luck and God bless on the rest of your problems.